You don't understand the youngins. I saw it yesterday.
All right, so page 24. If you turn to the very back of your packet, here are the formulas that we've been working through. So we've done multiplication, we've done division. So if you see the multiplication, we are definitely always doing the operation that the name. Guys. Okay, so we're always doing the operations that is in the name for the radius. So multiplication, we're always going to be multiplying the radius, but the theta, we're not quite multiplying, we're going to be adding, right? How we discovered that yesterday. Division of complex numbers, we're always going to be dividing the radius, but then instead of adding, we're going to be subtracting the theta. So there's always going to be something operations-wise that's a little bit different between what we do with the radius versus what we do with the theta. Now today, we're talking about what happens if I took a complex number and I raised it to a number. So if I raise it to a number, I'm going to be raising the radius to the number, but then the theta is not going to be, it's going to be involving a different operation. It's going to be multiplying. Okay. So we're going to be exploring this powers of a complex number. We've done product of complex numbers. We've done quotient of complex numbers, and now powers of complex numbers. Okay, and then we're also going to talk about nth root of complex numbers. This looks really complicated, so I'm going to split this up into 2 steps so that we're not having to think in terms of having to do such a complex operation all at once. So I'll talk about that. But really, these are the final 2 topics of this unit. And then we'll get some practice with this. Monday, we'll do test review. And then Tuesday, it's ACT day, but in the afternoon, we'll still have 25 minutes to do another day of test review. And then Wednesday will be the test, and then help session during 4th period. Okay, yeah.
And so Tuesday, you're not taking the ACT, then you don't show up, or you show up?
Well, if you're not taking the ACT, then you are, I guess you can always just not come to school until the afternoon. But I don't think there's gonna be any attendance taken during the day because students will either be in the cafeteria or in the media center.
And it's only 20 minutes.
And it's only 25-minute classes. Yeah, so I'll show the. Do I have the? Yeah, I thought I had the schedule. Oh yeah, I do. Here's the schedule. Okay, so for anyone taking the ACT, it's only for those who've signed up. And so 8:20 to 12:30, it'll be help sessions for 9th, 10th graders. 11th grade will be in the study hall, will be in the auditorium, sorry. And then here's the class schedule. 4th, 5th, 1st, 2nd, 3rd, 6th, 7th, and about, 20 minutes. 20 minutes, except for 4th and 5th period. Those will be a little bit longer because of lunch. But then, 20-minute periods. Not a whole lot of time, but if you're here, we'll do a review. Okay, so if you're here, we'll make the most of that time. It won't be a wasted 20 minutes. Yes. I'm sorry? Yes, yeah. I'll put all the, I'll record the lessons. I'll update all the worksheets, and the keys will be online. Yes. Okay, so, and if you're not here, you can still, I'll still record the video. You can still watch, and you can still see what we did in class, and I'll update all the keys that you need to follow along. Okay, so page 24. Let's practice through this formula. So powers are shorthand for repeated multiplication, right? So if I have 3 to the third power, it's the same thing as 3 times 3 times 3. Okay. Okay, go ahead and copy this down. So if I have a complex number raised to a power, I can think of it as the radius raised to that power, but then the angle measure is going to be multiplied by the n. We're not going to raise the theta to the nth power. Okay. Okay, so let's look at the first example here. Find the power of the complex number in polar form. Answer in both polar form and rectangular form. So we're just always going to get to the polar form first, and then the rectangular form. You can think of it as r cosine theta, r sine theta, or you can just think of it as taking that radius and distributing through the parentheses, right? So maybe that's a quicker and faster way of thinking about it. Okay, but let's go through this step by step. Okay. Rather than raising this entire to the fifth power, we're going to separate it out. So if I want to find z to the fifth, I'm going to be raising just the radius to the fifth power. Guys, come on. Okay, and then we will multiply the n value through the theta. Okay. So we're just going to follow the formula here. My radius is 3 root 2. So I'm going to do 3 root 2 raised to the fifth power. Make sure that you put 3 root 2 in its own set of parentheses. My n is 5. Just want to make sure that we understand that n is the power of the exponent. And the formula says cosine of n theta. So cosine of 5 theta. Okay, plus I sine of n theta, so 5 times 5 pi over 6. Okay, so we'll clean this up, but we'll leave the cosine and sine so that we can call that polar form. So enter that in the calculator. Okay, you should get 18, but you want to make sure that you don't just do 3 root 2 to the fifth. You got to put 3 root 2 in a set of parentheses first, and then the fifth power can come after. Yes, you'll be in radian mode, but you're not going to enter this into the calculator for radian mode because you're just going to leave the cosine and sine, right? We're not going to do cosine. We will for rectangular form, but for polar form, you want the cosine and the sine showing. Okay, so 3 root 2 to the fifth. Oh, sorry, to the fifth, my bad. That's it. Okay, we really want to do this in exact form. I know that the graphing calculator is not going to do that. So if you want to split this up, you can think of this as 3 to the fifth and then root 2 to the fifth. Now root 2 to the fifth, now the 36 Pro can handle all this, but root 2 to the fifth, you have to understand that this is really root 2 to the fourth times root 2, right? So in your calculator, if you want to think of it as 3 to the fifth times root 2 to the fourth times root 2, otherwise the calculator is going to take that root 2 and it's going to give you a decimal value. But if you enter that in the calculator, 3 to the fifth times root 2 to the fourth, this will give you a nice whole number, 972, and then you can tack on that root 2. That way we can avoid getting a decimal value. Does that make sense? I'm taking that root 2 to the 5th, and I'm taking the root 2 to the 4th, because I know that's going to give me a nice clean number, and the root 2 will leave that alone. So that's my radius. Okay, you're going to multiply the n and theta, but you're not going to put it in the calculator just yet. You're just going to do so this is polar form. There's also the shorthand way of saying 972 root 2 CIS 25 power 6. Okay, so that's polar form. So rectangular form is just r cosine theta, r sine theta. Another way that I didn't talk about yesterday is just think in terms of distributing this through, right? So whatever this value is, multiply this, multiply to this, whatever this value is, multiply it with this, and attach the I there. So we can now plug in the calculator, cosine of 25 power 6. Make sure you're in radian mode. Okay, if you're using your graphing calculator, 0.866 is equivalent to root 3 over 2. I know it doesn't convert that decimal there, but that's, yeah, that's root 3 over 2. Okay, there's my r cosine theta. I'm just distributing this through. Sine of 25 power 6. You can imagine that it's going to be 1/2. Okay, do a little bit of cleanup here. This 972 divided by 2 is 46. Okay, next part, it says use multiplication in rectangular form or the power rule in polar form. I think we're going to do it this way here if this feels like it's a little bit cleaner. Rectangular form just means we're going to FOIL the cell 3 times, which we can do, but let's just practice going through a power rule. So what we're going to do is we're going to take this rectangular form, convert it into polar form, and then once we're in polar form, then we can raise it to the 3rd power. So right now we're just going to focus on the -1 plus root 3i. Get it into polar form, so Pythagorean theorem and inverse tangent. Then we can get it into this RCIS form, and then we can go through this form of power. Okay, so a couple days ago, right, we know that this is our A, that's our B. Our radius is just going to be square root of A squared plus B squared. Pythagorean theorem, right? Inverse tangent. Okay, which quadrant? Oh, you do want to make sure that you are in degree mode. It's just faster, easier to interpret that number if we're in degree mode. Okay, -60. All right, which quadrant are we in? Second quadrant, so we've got to add 180, right? Now that we have our r, now we have our theta. Let's get this into polar form, and then we can raise it to the third power. Okay, so now we're going to do what we did for number 1. Now we're going to raise this to the third power. Now that we have something that is the polar form of -1 plus √3i. So if I want to raise this to the third power, right? We raise the radius to the third power, but then what do we do with the theta? Multiply, right? So always slightly different operations. Okay, so 120 times 3 is 360. So when you have your cosine and sine showing, that's polar form. And if I want to convert it to rectangular form, I can just work this out, distribute the 8 through. Okay, again, use the either methods above to do the same thing here. So we have -1 minus √3i cubed. So we'll convert this to polar form and raise to the third power. So all this is going to kind of lead into something that we're going to see. Okay, but so do very similar steps as above. We're just going to go through the same process. Okay. Your radius will be the same, but your theta will be different. But now we're in which quadrant here? Third quadrant, right? So plus 180. now that we have a polar form of -1 minus root 3i, we're now going to raise it to the third power. So raise the 2 to the third power, but then multiply the 240 by 3. $720 is the same thing as 360. Resolve the cosine and sine. We'll get the same thing as before, right? 8 times 1 plus 8 times 0i. So look at these similarities here, right? So let's make some conclusions here. We know that -1 plus root 3i cubed is equal to 8. We know that's true, right? And also we know that -1 minus root 3i cubed is also equal to 8. Okay? So let's look at what the problem says. It says, what is cube root of 8 equivalent to? So the obvious answer is, if I just look at this number alone, cube root of 8 is just equal to what? 2. But if we know that -1 plus root 3i cubed is 8, then another way to think of it, cube root of 8 is also equal to what? What's the cube root of this expression? Just what? -1 plus root 3i, right? Right. If this cube power is equal to 8, so if I take the cube root of that, I can just strip away that exponent. I'm just left with -1 plus root 3i. And if I know that this to the third power is equal to 8, if I take the cube root of 8, that means I can take the cube root of this expression, and that is also a representation of cube root of 8. So we're going to see that as we plot these points on the polar form, we're going to convert it back to polar form. They're all going to be kind of equidistant from each other. Okay. So we know that the 2 is just going to be 2 plus 0i, right? So we know that's one instance. That's easy to plot. -1 plus root 3i, maybe that's hard to plot, but if we get it into polar form, that's what we have from before. Polar form is just 2 cosine 120 plus I sine 120. All right, that's easy to plot. All right, that's just theta of 120, radius of 2. And then the third option, what we just did, is 2 cosine 240 plus I sine 240, and that is -1 minus root 3i, right? Okay, now if you plot these points, you're going to see that they're all going to be the same distance apart from each other. Okay, so 2 plus 0i is going to go 2 units over on the x-axis. I mean, along the 0 degrees. Cosine of 120 We know 120 is over here. We'll go 2 units out towards that angle. And then 240 is down here. And we'll go 2 units out towards that as well. So you see how cube root of 8 on the polar graph is equal distance from each other. Okay, so we talked about powers of complex numbers. Now let's talk about roots of complex numbers. So this is where we have like cube root or fourth root or fifth root. Okay, is everybody good on this page? Okay. Okay, so we did multiplication, we did division, we did exponents raised to a power, and now we're going to be doing exponents as a radical. So this is the final one here. Nth root of z. Instead of z raised to a power that's going to make it larger, now it's nth root, it's going to make it smaller. Nth root of z is the same thing as saying z to the 1 over n. Okay, so this represents that we're dealing with a root, right? Either a cube root or square root, depending on what that n value is. Okay, so the formula for this is we are going to take that radius and do whatever operation that we're expecting. But now, instead of multiplying by the power, I guess we're still multiplying, but this n is going to end up in the denominator. It's going to be cosine of 1 over n theta. So yes, we're still multiplying, but we're going to essentially divide by n because of the fact that our exponent now has a variable in the denominator. Okay, either write it this way or you can have it in the denominator. They're the same, so whichever way you want to do it, they're both fine. Okay. Multiplying by a fraction is the same thing as dividing by that number. Whichever your preference. Okay, find all the distinct fourth roots of -5 plus 4i plus 12i. Okay, the formula is complicated, but I'm just going to have this split up into multiple steps. Okay, that way you can kind of just do each step that you recognize, and we'll do one step at a time. First thing is, let's get it into polar form. Okay, first step, polar form. So -5 plus 12i, go ahead and Pythagorean theorem to get the radius, inverse tangent to get the theta. Okay, degree mode is going to be the easier one to use here. Oh, sorry, -5. Okay, sorry, negative. My bad. Okay, which quadrant? Second quadrant, so we need to add 180. Okay, let's get into polar form. Okay, next up, apply the root. It says the fourth root. Okay, so we're trying to do z to the 1/4. Okay, z to the 1/4. So we're going to take that radius, raise it to the 1/4, and then we're also going to divide, multiply by 1/4 or divide by 4, okay, depending on whichever way you want to do it. So 13 to the 1/4 is the same thing as the 4th root of 13. Okay, 112 divided by 4, or we can say 1/4 times 112. Maybe dividing feels a little bit more straightforward. So now, okay, this is going to lead us to our first solution. Okay, it says find all distinct fourth roots. So because we're dealing with fourth roots, it's always going to end up with the same number of solutions. So we're looking for distinct roots because this is dealing with the fourth. We're looking for 4 solutions. Okay, so we have one of the solutions here. Let's clean up this solution a little bit. divided 112.119 divided by 4. And sine is the same degree. Okay, polar form, applying the roots. Now we have to look for the other 3 solutions, right? There's one solution. Fourth root tells us that we have 4 total solutions. So here's the third step. We're going to find the other solutions. Now, all the other solutions are going to be evenly spaced around 2 pi, okay, or evenly spaced around 360, okay, around the circle. So the way you find the solutions is you figure out what the interval is because we have 4 equally spaced solutions. So we're always going to divide by n. In this case, n is what? 4. Okay, so we're dividing by 4 or multiplying by 1/4. And so we get 90 degrees. So this is telling us that all of our solutions is going to be 90 degrees apart from each other. So to find the other solutions, we just copy everything down the same. We keep the same radius, cosine, I sine, all the same. We're just going to be incrementing our theta to the next degree measure. So we're going to add 90 degrees. Okay, so our second solution is going to be 90 degrees apart from each other, from the first one. Okay, so what's 28.155 plus 90? Okay, how do you think we can find the next solution? Yeah, add another 90. Yeah. And then the final solution, add another 90. Thank you. So it's a complicated formula, but if we just think in terms of, okay, there's 3 steps I got to do. Get into polar form, right? You know how to do that. We've been doing that since a couple days ago. Apply the root. So do the 4th root or 5th root or whatever the root is given to you. And then you divide your degree measure or your radian measure by 4. And then once you're there, then you're going to take either 360 or 2 pi, depending on whichever form it's in, divided by how evenly spaced apart you want it to be. However many solutions there are, I want it to be divided evenly. So divide by 4 is 90. So that means every solution is going to be 90 degrees apart. So you're going to keep adding 90 until you reach the number of solutions. Okay. Okay, I know we need more practice with this, so we're just gonna just kind of get as much in today as we can. Okay. So page 26, I'm gonna skip for now the power. I think the power is pretty straightforward, right? You raise the exponent to the power, and then you multiply by the inside measure. I think what I would like for us to practice more with is the roots. Okay. So let's go to page 27. All right, these are the ones that are the most complicated looking ones, right? Okay. Okay, page 27, 8, 9, and 10. I just want to walk through these problems with you step by step. Okay, so first thing, 6th roots of I. So this is really 0 plus 1i, right? If we get into complex form, it's really 0 plus 1i. I don't think we even have to go through the full inverse tangent, because I think we can just graph this and figure this out, right? What's the radius? 1. And if you graph this, right, what's the radian measure? What's theta? Yeah, pi over 2, right? We'll leave it in radian mode since that is what we need to be working with. Okay, so let's build our polar form first. Okay, that's the first step, right? Get that polar form going. And now the second step is we want to find the 6th root. So we want to find the 6th root of 1, and then here we got to divide by 6, which is probably easier thing in terms of multiplying by 1/6. Okay. So let's adapt this here. So z to the 1/6 is equal to 6th root. Anytime you see a root, you know it's going to be 1 over that number. So the 6th root of 1, which is just going to be 1. But you're going to multiply that 1/6 through each of these degrees. Do a little bit of cleanup. Leave the cosine and sine alone. Okay, what we've done is we've reached the first solution. Okay, we've reached the first solution. How many more solutions are we looking for? 5 more, okay? And they're all going to be evenly spaced apart. So we'll do 2 pi and divide it by what? 6. which is pi over 3. So that tells us that to find all the other solutions, we're going to take the first solution and just keep adding pi over 3, pi over 3, pi over 3, and then by the time we get to the sixth solution, that's how we know to stop. But everything else is going to stay the same. Okay. So we're going to keep adding pi over 3 to get to the next solution. Okay, so second solution, keep everything the same, the root 6, the 6th root of 1, the cosine, the I sine, you're just going to add pi over 3 to pi over 12. You use your calculator to 1/12 plus 1/3, okay? Okay, so 1/3 plus 1/12 is going to be 5/12. Okay, it's tedious, I know, but it's not hard, right? As long as you can remember each of the steps, you're just now getting to all the solutions here. Keep adding 1/3. Next step is 3/4. Add 1/3 again. 13/12. Add 1/3 again. 17/12. And then add 1/3 again. 7/4. So once you get to the first solution, then you really have to just remember, all right, I got to make all my solutions evenly spaced apart. Use the whole circle divided by however many parts I want, and that's the increment I'm going to make. Yeah. Okay, let's just try number 9, and then we'll be done for the day. Okay, just one more. Find the radius, find the theta, build your complex number in polar form. Okay. Yeah, go back to degree mode. It's just easier to interpret with degree mode, right? At least for this part. But we got to bring it back in terms of theta because it's ultimately asking for radian mode. Okay, but for now, I think it's easier to do it in degree mode just to recognize the angle. Okay, which quadrant is this in? Fourth. Okay, so add 360, right? Okay. .330 degrees. If I want to convert it to radians, I can always do times pi over 180. You can also recognize 330 as closest to, it's a variation of pi over 6 in the fourth quadrant, so 11 pi over 6. All right, let's build our polar form. Fourth root, so we got to raise it to the fourth, or the 1/4, right? Z to the 1/4 is the fourth root of 8. And I need to multiply each of my measures by 1/4. (11 pi over 24). That's my first solution. Okay, I have one solution. How many more solutions are we looking for? 3 more. Okay, I need them all evenly spaced. So how do I get there? Yeah, 2 pi divided by 4, which is pi over 2. So you know that every answer is going to be separated by pi over 2. So you go keep everything the same with your first solution. You're just going to keep adding pi over 2 in your calculator to get to the next interval. (23 pi over 24). Okay, repeat the process, add another 1/2. And then one more. (47 over 24). It's the last solution. Okay, very tedious and very long, but hopefully by stressing the fact that thinking of it as 3 separate steps rather than one giant formula, hopefully that makes it a little bit easier to digest, right? Get it into polar form, go through that root process, get the radius and the theta adapted, and then figure out what the separation is for each of your solutions, and then just keep changing the theta measure until you reach the number of solutions you're looking for. Okay, let me just check a few pages here. 24, 25, and 27. Okay, 24, 25, and 27.